Luca, thank you very much for finding the time to deliver this to us. And it's over to you.
Thank you, David. So, first of all, welcome everybody. And our goal today is going to be to build what we on what we saw last time about Relay. So, on the last session, we found out what Relay was and how it could be used in general. We look at some of the methods, but there wasn't enough time to actually build something or to show off an application built in Relay. So for today, I would like to focus on practical development. We'll start with the Ruby app because it's well, it's not my favorite language, but this language I most often use when I'm doing development. And the Relay APIs and SDKs are built in a way that most of the methods and parameters carry over, so that shouldn't be a problem. That said, we'll try to cycle languages, so every subsequent session will be using something different. For example, next time we'll be probably doing something in JavaScript because there will be some client code involved. So first of all, just a quick recap of what Relay is. Relay is a real-time WebSocket call control protocol based on based on JSON. So all messages are propagated via JSON. The difference with doing things with Lamels, so doing them the HTTP way, is that the Relay connection is always up and it's always reachable. So you have a context that's being reached by inbound calls, or you can send tasks to your consumers, so you can do outbound dialing. All of that is in the previous installment. I have a couple links we'll send out later with the slides, etc. But for now, we'll assume all of that is more or less known, so we'll go over a few things. So first of all, if you're going to follow along, the first thing you need is a SignalWire account, which I assume some of you already have. But if you don't, just head to the SignalWire website and sign up. We'll need an API key and credentials from your space. It's very simple. Okay, so let's say I'm starting. So spoiler, I won't actually be, I'll be doing some live coding, but I'll try not to do too much because it's generally boring to look at people writing code. So what we'll do is we'll go through the various snippets, see them in actions, make a few modifications, and see the changes as they happen. So you need an API key because, of course, Relay needs the ability to connect to your system to the SignalWire system from your platform, whatever it is. Note that I'll be running a Relay locally on my computer. That's because one of the good things about Relay is that the consumer can connect, is a connection to SignalWire, and it can traverse most firewalls due to being just HTTPS traffic, essentially. It's WebSocket secure. So that allows you to run a consumer behind a firewall without having to worry about open ports and all the various things that usually you have to contend with, even just when running a web app. So at least you need a port for the web app to be reachable. In this case, you don't need it to, because it's going to be all running on a single connection that's initiated from the consumer towards the SignalWire systems. First of all, since we're talking about Ruby, we'll need to add a quick Gemfile to the project, and we'll need to also add an env file. So, of course, the required gem is actually SignalWire, which you can just stick in as SignalWire. I've added the .m gem because I very much like using .m to manage my variables for an application, even if just a simple app like this. That allows us to set a few environment variables. I'll show you in the editor. We have another couple variables we need there. But the main ones will be the project key and the SignalWire token. They need to be named like that so the consumer automatically pick them up. So SignalWire project key and SignalWire token. Project key is going to be your project ID. Token, you can create multiple tokens per project. Just grab one. Okay, so before we delve into an actual working application, let's take a look at a very, very simple consumer. What this consumer does is subscribe to a context named incoming and answer a call and just say the typography testing phrase, the quick brown fox jumps over the lazy dog. So what happens here is that, as you can see, we're simply subclassing a consumer from the SignalWire Relay consumer. Up one line, we're just setting the bug level to, the logger level to debug. I generally use this for most running code. Relay can be very verbose because there's a lot of JSON. We'll see that in the console in just a second. So as a result, I will suggest you only run at this level debug when you're actually debugging. Otherwise, you do generate a lot of logs. Then we subscribe to a context. So as you can see, the context is a class method, so it's just static. Just pass it an array context. Context a label, so a way SignalWire uses to route calls to a specific context or to a specific group, essentially. This allows you to run multiple consumers. One could be subscribed to incoming, one could be subscribed to messaging, and one could be subscribed to tasks, or whatever names you can give it. It's really just strings. That way, you can separate your consumer into groups. Multiple consumers subscribing to the same context will all receive the event that signals the beginning of a call at the same time. First one to pick up the call will win, and the subsequent ones will just be hang up. So you can effectively, this is going to do some kind of round-robin load balancing without you having to contend with it. There's a typo here, probably due to the autocorrect, so I'll fix it right now because I don't like having non-working code. As you can see, oh, that's interesting. This is not letting me add an underscore here. Weird. Well, I'll fix it later. This is very, very interesting. Whatever. It's something with the font size, or who knows. Okay, so let's say we have a consumer like this, and I have it ready, and we can run that in just a second. First of all, we need to point a phone number to the incoming context, or the call will go nowhere. So what I'll do is I'll go to my dashboard, grab one of my phone numbers, which is already set up here as, sorry, I have so many. It's a 707-400. Okay, so it's already set up like this. I'll do edit settings. Let me just check on the screen size so it's easier to see. Perfect. And as you can see, what we have here is the phone number. You can set a friendly name that doesn't matter to us. What's important here, we'll tell it to accept incoming calls as voice calls, to handle calls using relay, and then we'll say calls want to go to the incoming context, which matches up with what we had in the consumer, if you remember. So what we'll do here is, instead of running the assistant consumer, I'll just run the simple consumer. Sorry, let's see. So let's see what this does when I run it. First of all, we'll make the font size a little bigger so it's actually readable, and maybe I wanted to disable transparency, but I don't remember what that is, so we'll just make do with it. Okay, colors. Window. Okay, sorry, just took a second, but it's much better for everybody. Okay, let's go back to what happened here. So when I run the consumer, we got a few debug messages, of course, about things getting started. We'll connect to relay.signalwire.com. And as you can see here, I'm connecting using my project and token, which, well, I will change later, so don't use them. After the connection, we got a few things, including our response to the sign up, where effectively SignalWire is telling us, okay, you're registered. Then we subscribe to a context. We're subscribing to the notifications by default, and we're also subscribing to the incoming context. All this doesn't really matter to you. Like the relay protocol itself is documented, but it's something that you will almost literally never have to contend with. The SDKs have all the methods related to these objects. I just like to look at the debug mode when I'm working on a new application or just showing people relay, because this way you figure out where to look if something is going wrong. For example, as you can see here, we're getting back a message that tells us that the subscription went well. So we are now subscribed to the incoming context. That's quite important. So the console will almost always tell you what's going on. So if for some reason something doesn't work, after that, there's just a bunch of pings. So SignalWire, the SignalWire SDK pings the server to make sure the connectivity is still active. As you know, WebSockets can go idle, and there's no super precise way to tell if a connection is up or not. So this is how the client tells, just by pinging the other end. So I'll now try and call in, and we'll see what happens in the console. Well, so I got the playback, but more importantly, what happens here is that we're seeing a call come in from number to number. We're seeing the call being answered, as in the code, and then we're seeing a playback somewhere in here. Play TTS, and the parameters are the text of the playback, the language as defaults to US, and the gender, which is female. Of course, if you go look at my code, it's much simpler because the most of those parameters taken care for you. Of course, after the call, we hung up. So in this particular case, hang up could have been omitted, because what happens is that when you get to the end of an incoming call method and there's nothing else to do, the call will get hung up. There's an exception, which is the when a call is bridged. So when you're talking to someone else, and also if there's a component active, the call will not hang up, which means that in the upcoming application, we'll need to do things slightly differently to make sure things are handled in the correct order. Okay, so set up your number. We'll keep the number. So keep in mind, when we set up another consumer that does a different thing, which is going to be our special app we're going to build during the session, the context can stay the same. Of course, if for some reason you want to use a different context, remember to go change it in the number. Otherwise, it just will one route. If a call doesn't have a handler, so if you have no consumers up, when a call comes to the incoming context, it will just hung up, will fail because there's nothing to pick up. Effectively, as in the number wasn't connected. So make sure you have something taking those calls, or it just won't work. Okay, so that we just saw what happened. I tried the consumer, and it just worked. Generally speaking, that's how it's supposed to work. Again, it's very simple, and it's doing nothing special. Good. So now maybe, and not maybe, would actually like to do something more interesting, right? So let's build an interesting application. Say I have a phone number I want to put on my website. But as you know, if you put your phone number on the website, you're going to get all kind of calls. Humans are smart enough, but at least robocallers and automated calls will not be able to reach you if you have one simple trick. So what I want to avoid is having robocallers call me. So what we came up with, there's many ways to do it, but a way we came up with is doing a voice CAPTCHA. So you're all familiar with the various types of CAPTCHAs. So click on all the images that show bridges, or type in the letters and numbers shown in the above image, which is usually very readable, and I end up failing one or two of those every time because I can't tell what's in there. Also, they all use V's and W's, so it's impossible to tell. Voice is a little bit easier. And the other thing I want to do here is show you how to do an async detection event so that I have an in-call assistant to help me with customers. So there will be two steps. One step will be call comes in, and we ask the person to caller to pass a voice CAPTCHA. If they don't pass the voice CAPTCHA, it means they are a spammer, and we flag them as such. Of course, internally to this application, since I wanted it to be self-contained, there's no real database in there. We'll be storing the phone numbers in an array in memory. So as long as your application is running, it will remember who the spammers are, but otherwise it won't. How is the CAPTCHA going to be implemented? We'll get there in a minute. So first of all, let's see how we'd write up a quick incoming call handler. Again, very, very oddly, the autocorrect is not letting me put an underscore in here, but the code has it, so I have a link later. First of all, we need to remember to answer the call. Not answering the call might trigger some weird behavior if you play media before the call is answered. Most of the other events, including record or gather or really anything else, will answer the call for you, but I just answer it just in case. So don't rely on the fact that the following line, which I'll explain in a second, will answer for you. Just answer the call. This is because not all carriers behave the same way, and SignalWire, of course, works with the top carriers in the industry, and they do handle early media correctly. But the other end might be pretty much anyone. So sometimes early media doesn't work. What early media is, as an aside, is playing any kind of audio into a call before it's censored. The ringtone is early media. But in that early media space, you could be playing anything. It's just the ringtone being played is just a sound like any other. So to avoid issues like that and having to find out what's going on with your app, and maybe you can't tell, you're missing media on one channel, ends up generating some pretty weird situations. What you want to have here is just answer your call. Secondarily, we'll start to record the call. This is just more or less just for the debugging purposes. So I want to listen to what's going on in the call after the fact. So what I do is just start it as async. Note call record with a bang. That bang symbol means the method is async. So what this effectively does is no matter what happens on the call, just keep recording the call. End silence timeout means 0 means the call doesn't end on the recording doesn't stop on silence. For example, if I'm talking to someone else and one of us doesn't speak for 3 seconds, if you leave a timeout in there, it will stop the recording, effectively truncating the recording. While if you put it at 0, it will just keep recording until the call is done. Stereo through is useful because it will give you the separate channels. It will come in handy in a second when we'll see that we're playing audio to one channel or the other only, which is tricky and interesting. So the rest is just really logic. So we have a method, known spammer, that tells us if the caller is in our spam database. If they're a known spammer, we just send them to the handle spammer database. So it's handle spammer method. If they're a known caller, that is, they already called us and they already passed the CAPTCHA once, we just want them to talk to us. So we'll go to the connect human method. If they haven't called before and we don't know if they're a spammer or a human, we'll just send them to the CAPTCHA. When all of this is done, so we're forking out into the various methods, the call flow will ultimately come back here. And at that point, we'll stop the recording handle and we'll log the URL for the recording handle. This, of course, in place of that logger.info, you probably want to do something like store that into a database, post it to your web service, whatever. Otherwise, you will have to recover it from the logs of the application because the URL is showing there, but nowhere else. First of all, let's set up a few things. We'll take a look at the finished product in a minute, but I prefer to go through parts and steps so I can show you the thought process. So the first thing I will do is we need those two quotes databases. One is for humans and one is for spammers. Of course, this method can and should be replaced by something more robust. So the ready method, ready is defined in a consumer as the method that is called when the consumer is ready to take calls. It's where you'd set up database connections and whatever. So think that humans and spammers set up with an empty array could be a connection to a database or whatever. Of course, at the same time, in the same way, the known caller method and the known spammer method are really just a check into those arrays for with call.from. Of course, this could be far more complicated, and it should be either an HTTP request to your service asking for the number check or a database dip directly, something like that. A relay consumer is a long-running process that is multi-threaded and concurrent capable. So you should be able to run, in Ruby at least, with most database adapters, including active record. Just watch out for thread safety of your own code and database adapter. The consumer itself, it's thread safe, but of course, you have to make sure anything you introduce from outside should be thread safe too. So now we have a consumer that knows how to tell if someone is a caller, it is a known caller, or someone is a known spammer. Let's get to the meat of it. This is a slide I added because I like people to have a look at code in the slides. But I'd actually prefer going to the editor here, which is going to be a little bit more readable because I can make it bigger. Okay, there we go. So you recognized the context setup, the helpers from before, and then the incoming call handler. Let's go to the meat and potatoes of what we're doing. So our CAPTCHA is going to be a simple test that is a sum. We're going to ask the caller if they are we're going to ask the caller if they know the result of a sum. So we'll generate two random numbers, that is 1 to 10, and ask them, hey, how much is 5 plus 4? If they answer correctly via voice or via the TMF, we can be reasonably sure they are a human that's wanting to talk to you for some reason. Might not be always the case, or who knows, but it's so people are getting smart. And you can also write the evil part of this. Like, you could easily use Relay to dial into complex IVRs and even to defeat CAPTCHAs. I was thinking that you could write a Relay app that dials into this very CAPTCHA, uses speech recognition to extract the numbers, and makes the sum into code and just responds correctly. You totally do that. That could be an interesting exercise, and I'm actually going to try and do it over the course of the week. But let's go back to what we're doing here. So, of course, we're doing the usual stuff. So we give people 2 tries. We'll start with the assumption they're not spammers, and so this is the first interesting thing. So hints. Hints are a way for the SignalWire speech recognition engine to know what to expect. It's not a grammar, because the speech recognition engine will return terms that are not in the hints, but adding a list of hints makes it much easier for the engine to detect the correct input, and also it will return the input in the correct format. What this means is that the hints 1 to 20 2A, which are really just in Ruby, this means, oh, I closed my Pry console, sorry. What it is in Ruby, for the people that are not used to Ruby, is just an array of 1 to 20. So what putting that in as the hints tells the engine is to expect numbers from 1 to 20 and to return them in digit format, which is the important part. Of course, nitpickers will notice that 1 is not needed, because the sum can never be 1. Why? Because we're generating 2 numbers. First number is 1 to 10. Second number is 1 to 10. So the sum actually is 2 to 20. I just noticed. I suppose it doesn't really matter. Okay, so first of all, we'll tell people, hello, prove to me that you are a human. And then we'll generate the 2 numbers, and it's time to look at a few parameters. So prompt TTS. People that were following along from the first installment will remember that prompt TTS method as being quite interesting and complex. Here we're using it almost to the maximum of its own features. So we're using it to detect both digits input and speech input. And we're asking how much is 7 plus 4. So let's go through the parameters in order. Type both simply means expects both voice input and DTMF input. Digits applies to DTMF and tells the engine to wait for a maximum of 2 digits or to time out after 1 second. Effectively, this means that if you don't enter either if you enter 1 digit and not the other after 1 second, it will just fall through. You can use a terminator. Some people are used to using a terminator even if you don't have that in your prompt. So they will press 1 2 hash. It's fine, or the pound key in this case. And you can. This also sets a silence timeout for speech. Last, we set the speech hints we went over earlier. So we tell the engine to expect the number from 1 to 20. And then we just tell it to say how much is first num plus second number. So prompt TTS used like this is blocking. Note doesn't have a bang pad here, a bang symbol here. So this will wait until something happens. And it will ultimately just give us an input result, which will convert to an integer here, because it's coming back as a string. It's being recognized through speech, so it will be a string. And then it will be added well, we'll add together the first number and the second number and figure out if the sum matches. So if the sum matches, we're happy that the user isn't a spammer, and we'll break out from the while loop here. Otherwise, we'll temporarily flag them as a spammer and have them ask again if there's a and have them ask again for the same question. So we'll say that is wrong. You have remaining more attempts. I added this if remaining more greater than 0, because otherwise it will say you have 0 remaining attempts, which is not what you want to do.
Luca, it's David here, just jumping in for a minute. I just wanted to highlight some questions that have popped up in the chat. And if you'd care to take a look at them, not necessarily to answer them immediately, but maybe that would be useful if you could.
Okay, so the client is just the consumer that we're looking at. So a consumer class is all you need to run calls against SignalWire. So there's nothing else you need against Relay. Just build your consumer and have it run. If it's configured correctly, we just connect. Deployment is a, well, depends on what your setup is, because you can, I mean, this is just a Ruby process. You could run that in Docker easily. Just run it literally on top of any Ruby image, and it will just do bundle install and then run. Or you can run it any other way. This is just the ease of use here, which is something we really strive for, is that a consumer is just a Ruby process that only needs connectivity towards SignalWire through a WebSocket tunnel. So anything else is not needed. That really, really helps, because that way you can more or less run your application almost anywhere. It can be firewall, we'll run on AWS, or we're running anything without any particular change, because it would just connect by itself. Hope that more or less explains it, but we can take a look later at the deployment in a little bit more detail if you'd like to. I don't have a Docker file handy, but I can go grab one.
Honestly, I visited the questions. I'm not very sure about I think your lecture your topic very interesting, but I don't have a bigger picture. Bigger picture means, for example, I'm a developer, right? I think it is for developer, right? It's not for end user, right? I'm a developer. I can write for whatever language, right? So how I use these features, right? I know we need to pay for synchronized relay, right? We need to pay for the API. So this in here, for me, I'm a developer. How I write an application, for example, I write in Ruby or whatever, in JSON, or I'm in JavaScript, right? How I deploy the application, right? How I deploy my application. For the case, you raised a very good example, right? I put my number on website, right? On my website, for example, I want someone to call me, right? This is very quick example. But I don't know from my point of view, I don't know how to deploy application. Also, what's a client to use? For example, I put my serial number. My serial number is a serial number on my website. So does that mean my client is my cellular phone? So I just want to say, I'm a technical guy, you are a technical guy, but I think would be better to give us a bigger picture first, and you drill down in the detail too quickly. So I think I missed the bigger picture.
Yeah, we did the first installment in Relay last month, so I think that's somewhere on YouTube, so we can get started from there. But really, the picture here is not very complicated if you're doing just a demo. So first of all, you literally need one class that is your consumer that's subscribing to the incoming method, the incoming context. You need to run that in your console, and then all you do is you go to your where's my?
I understand. I understand that from a programming point of view, it is simple, but I don't. Honestly, this is the first time I heard about a relay. The name come out many times. Really, I heard about the synchronized relay. I use free switch daily. Okay, I heard about the relay name come very many times, but I don't have a bigger picture really. So little bit okay. This is the reason I ask these questions.
Yeah. So as I was saying, you'd run the application when the application is running. Just go to your SignalWire dashboard, set up a phone number, and have it send a call to your incoming context. That's really all there is to it. Once you call this number, the call will end up in your consumer. It might be, it might look almost too simple, but it's because we made it simple on purpose. It is the idea is that getting set up should be as seamless as possible. We did do some more base setup development earlier, but of course, in the first installment. But of course, this one is more or less about the application. Generally speaking, though, what you're looking at is just it. There's nothing else. Have a consumer, run it in your console, and then have a phone number call into that incoming context. That's all there is to it. Nothing else.
So
I think that is something to remember, that this is part of a series, sir. And so Luke has kind of progressed to the next part along. Two things to say about that. Number one, as Lucas said, the other video is available, and it might be that watching that one prior to then re-watching the video of this, because this is going to be recorded, or this is being recorded and will be put out on the SignalWire channel, would be a useful thing. But also, every second Friday of the month, we also have a clinic, a live clinic that Luca is a part of, in a room like this, where people can come in and ask free-form questions as well. So, I hope through those different ways, we will help you get to the point where you will be doing your own SignalWire applications.
So, thank you so much. So one more question. Does that mean this application, this Ruby application, is run in a cloud, or run in your SignalWire cloud?
It's a Ruby process. You can run that anywhere. I would suggest using Docker just for the ease of management, but really it's just it is just a simple Ruby process. You can run that mostly anywhere. Anywhere you can run a Ruby process.
But even run on my local machine. Can you run?
Yeah, that works too.
So then how did the call object? I mean, how the audio come to my local machine?
No, audio is staying in the cloud. What the relay is doing is controlling the call.
Okay, got it. Okay.
Relay is it's what will be termed the third-party control protocol. So what you're doing here is you're giving the SignalWire cloud instructions to do things, but you're never actually getting the audio locally. It's a different thing. Yeah.
You can make it more clear now. Thank you so much. Yeah. Yes.
Okay. Perfect. Yeah. That's actually a very good point that I sometimes skip over. Yes, the audio is never leaving the SignalWire cloud. What you're getting here is that effectively your relay application is sending commands to the server side.
Okay. Got it. Very clear. Thank you so much. We hope. Yes. Yeah.
Thank you. Okay. Good. So going back to what we're doing here. As you remember, we were just checking the sum, and then we'll do if the caller is a spammer, we will just look back to the request, ask them once again, that's wrong, you have one remaining attempt, and then ask them for a different number, really. What is this? So asking them for a different number, the same number, will just be application logic. You decide if you'd like to have the numbers reused or not. Doesn't really matter. The idea here is that it's just a demo. So asking for a different set of numbers, it's probably better because it defeats some sort of automated attacks. Cool. So of course, at some point, we'll exit the loop here, either through a break or to reaching the maximum number of tries, and we'll find ourselves here. What we'll find ourselves doing is, if the isSpammer variable is true, we will add the caller to the spammer's database. Again, this line should be, in a real app, should be something like an insert to your database or an HTTP query to your application telling your DB to remember this number. And then we'll go to the spammer handler. If they pass the CAPTCHA, we'll put them in the good people corner, in the humans corner, and connect them to us. Okay. Of course, again, let's see what happens to a spammer. As you can see here, I went with something simple. This is where my comment says, this is where we could have fun with them. They will let them off easy this time. So in another installment and in a JavaScript example, which I will put up somewhere so we have it linked, we have a Lenny implementation. Lenny is a time-wasting bot that was developed by a few people that were really, really angry at robocallers. And Lenny is cool. It's just a set of recordings, but the way it's set up with an attention-getting mechanism is enough to fool people into thinking they're talking to a person for some time. So eventually you realize you're talking to a recorded voice. But at that time, by the time you get there, generally speaking, you have wasted 1 minute or two, which is totally fine. And it's just making spam calls less economical. So it will just be more expensive. Spamming costs more the longer the calls are. So suit yourself. So for now, we'll just tell them not this time, spammer boy, and slam the phone on their faces. Of course, this is, again, we could be doing a variety of things, including just hanging up. But this is, for now, this is what we'll do. Just set it up. The JavaScript version has it here, and I'll just show you very briefly what we do. Lenny method here. Effectively, what we do is we will find a random attention getter. So Lenny is divided into, Lenny is just a set of recordings, and it's divided into two main classes: attention getters and response getters, which are phrases that will either greet the other party or ask a question. That makes it so it's, it can actually pretend to be a person for quite a while, because it will say, hey, hello there, how can I help you? And the caller will say, I'm trying to sell you something you don't need for a lot of money. And Lenny will say, oh, how cool, tell me more about it. And it will take at least a couple interactions before you can tell it's not a person. At that point, you're already wasted a minute or two, which is just great. We'll do this in a following installment because I wanted to show you something even more interesting. Okay, so right now, then we'll make a couple test calls just to see things in action. And unfortunately, I did have a technical problem, so I don't have system audio piped into my Chrome window right now. But I'll see what I can do, or just show you the logs. Logs effectively show the same things that are happening in the call, so we can do that too. But let's see, first of all, what we do when we go to a human. We'll log in. This is where we'll dial out to ourselves. I will play some TTS that says connecting you to my master, which is absolutely quite not appropriate, but just something to say. Could just whatever. Please wait or something. The connect method that we have on line 92 can be a little bit tricky to decode. So we're working through this part of the SDK to make it for a bit more user-friendly. But for now, you can see it's actually expecting a nested set of arrays. What this is, it's because Connect supports dialing out in parallel and in serial at the same time in groups. What this means is, dialing out in parallel means I am dialing to 3 phone numbers. I want to dial them at the same time. First one to pick up gets the call. The other 2 numbers hung up. So that's dialing in parallel. Dialing in serial means I dial the same 3 phone numbers, but I dial the first one. If they don't pick up, I dial the second one. If they don't pick up, I dial the third one. This is a very common PBX/dialing behavior in general. What you'll want to do here is that our connect method supports serial dialing of groups of parallel numbers. So you could be dialing, first of all, you could be dialing 3 numbers, the 3 main support people number, at the same time. First one to pick up gets the call, others get hung up. None of them answer. I then want to dial 2 more numbers, which are our backup support technicians, again at the same time. So serial of parallel. You could do it. You could do vice versa. So you could do parallel dialing of serial numbers. It gets very complicated, but you get the gist. Point is, there's a couple areas in here that can be abstracted away, and we'll make that a bit easier in the next release of the SDK that's being worked on. For now, just use the method as is, and you won't have any problems. What connect does, going back to the origin, is create a new call to what number? To the number that's env.number. Let me pull up the env file for you. So as you can see here, I have a token, the tokens, and then I have a from number and a to number. I set them up just briefly to anything I need to do. I just have it there instead of having to remember the numbers. But more likely, two number is effectively my phone number, the number I am on. And that's the number that's supposed to be my cell phone number. So it's the number I am screening calls to. So 2 number will be my cell phone. Anybody who calls in and doesn't pass the CAPTCHA will just get sent to spammer hell, while the anybody who passes the CAPTCHA will get through and talk to me. And the from number we're using is simply call.from. What this does is, on my phone, I will see the call coming in from the same number that was originally dialing into the application, which is, generally speaking, what you want to do. There might be edge cases, there might be different ways to handle it, but generally speaking, that is what you want to do. So usually when you're doing, this is a type of call forwarding. When you're forwarding calls, you're allowed to use the incoming call phone number as the from number. Keep in mind, this is the only case you're allowed to use a phone number as a caller ID that is not either a number you have purchased from SignalWire and is on your account, or a number you have verified with SignalWire. You can verify numbers that are not hosted by SignalWire by using the verify number page on the dashboard. You will receive a phone call, and the phone call will let you know 3 different 6 digits you have to enter in the page. If you enter those 6 digits correctly, from that point on, you will be able to use that caller ID for outgoing calls. This is effectively an outbound call, because what we have here are 2 legs. One is the call that came in, hit SignalWire, and went to the consumer. They went into the CAPTCHA, or they were already registered as humans, and now they're waiting. So right now here, they're waiting for something to happen. What they're waiting for is the call to be originated out. So this is a second leg that will call my cell phone, or my desk phone in this case. After the call is connected, this is a blocking method. So what happens here is that the blocking method will wait for the call to connect before it passes control back. And it will store the handler for the new call, because I have 2 calls here. One is the call coming in, and the other is a call coming out. Generally speaking, those are different calls. So they're connected to each other, of course. And what we do here is we then activate a detector. Activating a detector is, well, this is just a quick demo I did. So this is to show off how you can easily do async events in a SignalWire call without any problems. So what we do here is I set up a detector for the other call. So let's be a bit specific here. This is not super easy to follow, but that's how call goes. So let's figure this out. So we're calling activate detector, passing it as parameters the call object. The call object is the call that was the inbound call. So the call someone dialed that got to my relay application. The other parameter we're passing is the call handler.call, that is the call that I just connected. This is the call from SignalWire to my cell phone. Of course, since I want to be the one to be able to activate a application of sorts in my on my call, I will start a detector on the other call. Other call should probably be named my call, but whatever. But we can easily do that if you like. So it could be my call. That's easier, probably easier to read this way, right? This is easier. So my call is the call on my end. So what I'm doing here is I'm detecting digits on my end, waiting for, I'm only allowing for digits 1 or 2. And well, timeout is 120 seconds because there's no infinite timeout on detect. It should be made longer because, of course, you'll probably be on the phone longer than 2 minutes. I just set it up that way because it's an example. This will actually be blocking within the method. So to build somewhat complicated relay applications, you do need to pay a little bit of attention to the flow of the application. What happens here is that I'm currently on the phone with someone else, and the detector gets started and waits for a digit from me. Only I can trigger that. The caller cannot, because the detector is specifically working on my call. There is no way to detect the digit on both sides, So what you do here, if you want to detect the digits on both sides, you start another detector, call it another detector, call.detect, right? Because the call is actually the inbound one, and my call is the outbound one. Then we'll just do something very simple. I just wanted to showcase it. So what we do is not important, but what we do here is that we're playing the day of the week to the other end, oddly enough. Why so? Because we decided to do this. Again, this will only be heard by the far end. There's a way to play audio to both legs, but it's tricky to look at. It's a complex method, and I'll leave that for questions, or if someone has something else to they'd like to implement. But for now, this will play audio to the other end. This actually could be useful. Like, this is something you could use to play your remaining credit to someone in a call without the other leg hearing it. So say you have a call set up and you're waiting for something two people are on a call, and you want to tell one of them, hey, your credit is running, you only have 2 minutes left, your credit is running out. You can do that using the various play methods on a single call or leg. That actually makes it very very powerful. The other end, if you press 2, I envision one idea that could be here is that I might be wanting to save the caller's name to a database. Say I am on the phone, I am on my cell phone, I have no way to take a note, but I want to make sure I call back this person because they have an interesting business proposition. I could set up my application so when I press 2, something happens to that number. Of course, we're not actually saving it here because there's no database, but then I play an audio message to myself that lets me know the number has been saved to the database. Again, the other end, so the caller will not hear that number saved to database audio. What will happen is that only I will hear it. So in one case, we have something being played on the other end. I know playing the day of the week is not really useful, but it's just a quick way to showcase something. While this number saved to database thing is probably more of a real life use case. I want this number to be saved to a quick list of people I want to call back. Of course, this could be even more complicated, this could be even more complicated, and but you could, after saving the number, you could add some metadata coming from the call, of course, like who's calling, etc. So quick question, why is it called Relay? Well, actually, Relay is the name that our CEO, Anthony Minasali, gave to this protocol, and I think it comes from there. Generally speaking, it's relaying your commands from one telephony server to another and from your service to our servers. So again, as we were saying earlier, Relay doesn't really touch the media. It's just doing a set of commands. It's a third-party call control protocol. So this could be said as in relaying your commands to the system. Going back to what we're doing here, once the detector is done, we'll just wait for the call to end. That makes it the call blocking. If you don't have this in, what happens is that when you press the DTMF, the TTS will play, then we'll go back here and we'll hit the hang up because call execution will continue. So generally speaking, you want to wait for the other end to be hung up. This might look like a long-winded explanation, but honestly, look at the lines of code that we have here. If you exclude the code that's actually needed to run the consumer and a little bit of setup at the beginning, we're looking at 100 lines of code to set up a voice CAPTCHA and optionally to set up some level of in-call assistant. Of course, all of this could be more complete. All of this could have more business logic related code, but I wanted to showcase Relay. Everybody knows how to save a string to a database if they need to. And that's the idea. So I think we could start doing a couple quick calls and see what happens. So I have let me see if I can set it up so you can see both ends. So let me go grab my Bria. So what I have here is that I have set up the Bria phone you're seeing on the screen as the receiving end of the call, and I'll be dialing the call using a very simple SIP client I have running on the browser. because SignalWire is, in fact, I'll show you. Let's see if we can set up things in a way we can all look at everything at the same time. It'll work anyways because there's no video. Sorry. Well, as good as it gets. Okay, so what I have set up here is a very simple SIP.js client that will make a call to that phone number, get into the relay context, and then make the call go through. Unfortunately, if I take my headphones off, it will get echo because we're calling into the same device. So you'll have to trust me on this. We'll look at the logs on the other side, though. There's always something to see here. What else? Yeah, just as an aside, all SignalWire services are fully WebRTC capable, so you can use both the SIP.js client to access our systems via SIP, or well, not just SIP.js. I mean a SIP.js client, not just SIP.js, which is a specific library. But you can also use our Relay.js client. Relay.js is named like that because Relay is our underlying real-time call control protocol. Relay.js is the browser version that's effectively used to create a WebRTC endpoint you can use to dial into all of SignalWire's services. Cool. So let's see if this works. Here we go. $16. I was asked with. There we go. You see my Brea phone is ringing because I answered correctly. Hello? Hello? Just a bit of echo here. But if I press, note that we have a detector event in the console. And now we'll press 2. And we'll see the number being saved to database here. I did hear the audio. And now I'm going to hang up because there's a lot of echo here. Cool. So I had to hang up the other end, not because of how Relay works, but that's the SIP client I'm using that needs some changes. So we can go through the console probably, but the main thing is that we have a detection event running here, and then we have see if I can find you. I wanted to show you at least the 16 output. There we go. So as you can see here, we are asking, here's the output of what we were doing earlier. So we're playing a TTS, how much is 7 plus 9? And this are the hints. Hints will make it come back at 16 in digits, as we discussed earlier. I just said 16, which was correct. And then what I get here is, there we go. We got 16 back, and here's our logs. Caller said 16, and this is where we dial out to ourselves. Cool. Then it said connecting you to my master, and then it dialed out to my phone. After the connection was made, we have a detection event that I showed you earlier, and when the detect comes in, what we do is here, when the digit comes back, we trigger the playback of numbers saved to database. Note that with the detector set up like this, so with digits 1 and 2, 1 and 2 means accept digit 1 or digit 2. The detect digit will receive a single digit. Other digits will be ignored. If you press 3, nothing happens, and the detector keeps going until you press 1 or 2 or the call goes down, in which case the detector, of course, is automatically stopped by itself. Cool. So let's make another quick call. I'll clear the console just to make things easier. So I'm a human now. Well, if you remember, we were storing the actual list of humans into a simple array here. Sorry. So I had to actually restart the process. We'll do just another quick call since we started a little bit late. Let's go a few minutes more. I will place a call to myself, but this time $28. $45. There we go. So let's go back to the start. This time I just said something wrong on purpose, right? So the detector event, let me go get this for you. Okay, that's just a playback for the start. Okay. Format MP3 direction both stereo. This is the recording. Note here. So yeah, something I forgot to show you earlier. As you can see, the recording is automatically uploaded to our storage cloud. Those files are kept for 30 days, and you can download them through that link. They're just they're public links. We have the ability to set up private uploads for specific customers. So if you have a need for that, let us know. Okay, so I got asked how much was 9 plus 9, and I said something silly like 45. So clearly that's not the... So 28. I said 28. As you can see, it will still recognize 28, but the confidence is going down. Confidence means that the engine is not sure, because if you remember, 28 is not part of the hints list we had put in. So caller said 28, and the voice said, that is wrong. You have one more attempt, and then asked me again. And this time I was asked for how much is 7 plus 10, and I think it did say 45 this time. There we go. Events. There you go. 45. Of course, this is wrong again. So all we do is we log it. Caller said 45, and then not this time, spammer boy, and we just hang up on them because they're bad people. This is effectively a good way to handle things. If I call again, what happens is that I am in the database now, which you remember is just an array in the it's just an array in the memory of the process, because there's no real database. So it just sends me straight to spam, not this time, spammer boy, and hangs up. So I effectively banned myself from the system. Of course, in this particular case, what I do is I just stop the process, and there we go. Great. So this is really it. It's a simple and interesting way to use Relay. It's something that will be harder to do with other systems, and also showcases how easy it is to do async events, such as a DTMF detection. That's the presentation for today. I know it was quite a bit of code. I know it was quite a bit of interesting things. We'll put up the slides, and the code is already up on my guide's website, so we'll make sure everybody has the links. And I thank you for your attention. If there's any other questions, I'll be happy to answer.
Okay, very nice. Thank you so much. I have one more question. So, can I deploy over on my own Relay service? I know you're using SignalWire, right? Because we use FreeSwitch internally a lot. So the question
no,
is,
Relay is a SignalWire product.
Like okay, it's not open source, right?
Well, the protocol is, but the actual control layer isn't. Yeah,
okay.
It's specific for SignalWire services. I don't think FreeSwitch will even be capable of doing everything that Relay does, because not everything is in there. It's Relay is a mix of various technologies we've built over the course of the years. So yeah, no, it's a different thing. You will use ESL in that case.
Okay, thank you so much. Yeah.
Cool. So if there's anything else, otherwise I'll stop sharing my screen and defer to our MC, David, for the closing remarks.
Okay, thank you very much, Luca. Still here. I also wanted to remind everybody of the upcoming ClueCon in February the 16th and 17th. And more than that, as I mentioned to the gentleman that was asking the questions, every Friday, other than this Friday, because this Friday is Black Friday and everybody's going to be bargain hunting, but every other Friday of the year, we're there in clueCon.cantina.video at 10 a.m. Central Time, and different things happen different weeks, but the second Friday of every week is like the SignalWire Clinic Friday. So we have a free switch bug hunt on the first Friday of the month. On the second Friday of the month, we have the SignalWire kind of clinic where we go through very basic operations and invite people to ask their questions. And then the other 2 or 3 Fridays per month, we have different guests in that talk about different things. And guests in the past have included the guys from the Homer team talking about SIP CAPTCHA and diagnostics like that. People from OpenSIP's project, Bogdan and some of his crew, Daniel from Kama-Ilio, Dave Horton, who I think is still on this call, maybe not, don't know. But Dave has been on talking about some of the things that he gets up to as well. So we have a lively debate. So every Friday, ClueCon, in fact, I'll put the link in the chat. So it's clueCon.cantina.video. There it is. That's oh no, I'll put ClueLon. No, you can't have ClueCon. We don't want too much trouble there. ClueCon.cantina.video. That's the place to go every Friday. All right. I also want to remind you of the cabaret, the kind of Christmas do coming up on December the 16th. And more than that, in January on the 13th, we've got the free switch installation and basic configuration training for those that are new to the free switch open source project. So lots and lots of things to get involved in. And do remember to keep an eye on cluecon.com, where registration for the February ClueCon, that's ClueCon TGI 2021, is already open. I think that the only thing that remains for me to do is to say thank you for attending this. Luca, thank you for presenting and for going through that example. And as I mentioned to the gentleman, I think it's Kaidwan. Is that how I pronounce your name? As I mentioned, if you go to either the SignalWire or the Free Switch YouTube channel, you'll find the previous video, which was more basic introductory information. So with that, thank you very, very much. And you're free to go. All the best. Bye-bye.
Thank you.
Thank you, David.
You're very welcome.
Thank you, guys.